Hi there, you are watching a video of piping systems in industrial plants. The piping system of an industrial process plant is the most important item of all plant equipment. The cost can reach up to 50% or 70% of all components in a process plant and 15 to 20% of the total installation cost. Anyway, what is a piping system? Which components are included in a piping system? A piping system is a group of standard elements joined up by different means with the aim of transporting fluid from A to B, meeting the design requirements. In order to be able to specify a piping system adequately, it is necessary to know the pipes, how they are constructed, how they are fabricated, standard specifications, materials of construction, in which materials we can find the different pipes, fittings and valves, how they are selected, specified, different materials, and the different joining methods, how we are going to put the different elements in a piping system together. Pipelines are the main element of a piping system. They are standard elements having different manufacturing methods for various applications according to the requirements of a project. A pipe is specified according to its nominal diameter and its thickness. For the same nominal diameter, the outside diameter does not change. The nominal pipe size, NPS, is the identity of the pipe, not being coincident with neither the outside diameter or the inside diameter. This is true for pipes up to 12 inches NPS. From 14 inches inclusive and larger diameters, the NPS matches the outside diameter of the pipe. As mentioned before, pipes are standard items that are selected. The specification that defines the constructive characteristics of a pipe are ASME B 36.10 for carbon steel pipes and ANSI ASME B 36.19 for stainless steel pipes. Next, the different methods of joining piping systems will be described. There are three main methods for joining pipes: flanged joints, welded joints, and threaded joints. The joining method will be selected depending upon the operating requirements of the pipeline. Threaded joints are a great solution for systems with low pressure and temperature requirements, mainly due to its low cost, easy implementation and easy maintenance. These joints are tapered to prevent leakage, and fittings are available up to 4 inches NPS. The petrochemical industry do not allow these joints for process lines. Welded joints present good mechanical strength, the preferred option over threaded joints, especially for applications with considerable pressure and temperature requirements. Within the welded joint configuration, the following can be found: butt welded joints. This type of joint configuration presents the higher mechanical strength of all methods, being the most costly of all alternatives except for the flanged joint application. On the other hand, socket weld connections can be found. These joints are easy to assemble and can operate in a limited range of pressure and temperature. And finally, flanged joints are found. This method is complementary to previous ones, comprised of removable elements where interconnection, maintenance or repair is required. Flanges are available for the entire range of pressure temperature, being the most expensive joining method. There are many different flange standards to be found worldwide. To allow easy functionality and interchangeability, flanges are designed to have standardized dimensions. Some of the type of flanges most used in pressure vessels are welding neck flange, butt welded to the pipe, best standard flange regarding mechanical resistance, used when security is an issue, slip-on flange. The pipe passes through the flange and it is attached with an external and internal fillet weld. This type is less expensive than the previous and it is not used for high pressures. Socket weld flange, often used only for small pipe sizes, 1.5 inches nominal pipe size and smaller. Lap joint flanges. They use a stub end that is butt welded to the pipe. The flange drills do not have to be carefully aligned before welding, which simplifies the installation. Threaded flanges are useful when the weld is to be avoided, processes where flammable gases may exist, for example. And finally, we have the blind flange. They are used to cover end of pipelines, manholes of pressure vessels, and handholds. These flanges have standardized dimensions. They have been designed to withstand specific design conditions, pressure temperature range. That is why they are not calculated, but selected. Flanges up to 24 inches nominal pipe size to be used in piping systems must be selected from the ANSI B16.5 standard. When using this flange standard, the first step is to find the adequate chart for the flange material required. Then, the pressure class, or rating, must be determined from the pressure temperature range corresponding to the flange material. In other words, we need to select how strong the flange should be to withstand the pressure and temperature effects. Let's take a look at the picture. All flanges shown there correspond to the same diameter, and in terms of design requirements, class 150 is the smallest flange available. If pressure temperature requirements increase, we will need a stronger flange. Therefore, we will need to move clockwise towards classes 300, 600 and 2500. There are several types of flange facings. They are selected upon the seal tightness requirement. The most used flange facings in pressure vessels are raised face flanges. This is the most common type used in process plant applications. It is referred to as a raised face because the gasket surfaces are raised above the bolting circle face. Ring joint flanges are typically used in high pressure services, class 600 and higher, and or high temperature services above 427 Celsius degrees. They have grooves cut into their faces for steel ring gaskets. For RF flanges, steel spiral wound gaskets are normally used, and for RTJ flanges, these gaskets can be octagonal or oval. Gasket materials depend on operating fluids, being typically stainless steel SS304. In addition to flanges, there are different fittings that allow the various piping system configurations required by the process. Same as for flanges, fittings are standard items that are selected. Following the joining methods mentioned before, threaded socket weld or butt weld fittings are available. Valves are the elements that allow us to control the flow in a piping system. The various components comprising a valve and the main function of the different types of valves will be studied in this chapter. The specification of a valve is a complex process involving diverse definitions, such as the type of valve, fabrication material, the joining method preferred, threaded, welded, flanged, the operating pressure range, and the nominal diameter, for example.